discussing in our last class, as per the BPUT University and other technical university, the syllabus of the formal language and automata theory and the module 1, introduction to the finite automata, we have seen. Today we will see more on this finite automata. So, finite automata, okay, finite automata. Finite automata. The finite automata, again they do classify into three versions, or I can say DFA and NFA with epsilon, and another is called NFA without epsilon. Again, I repeat that. What exactly this finite automata do classified? It is classified either a type deterministic finite automata, DFA, deterministic finite automata. Second version, non-deterministic finite automata with epsilon move. With epsilon move. Another family, non-deterministic finite automata without epsilon. Now let us go into detail of that. DFA, deterministic finite automata. If you see this deterministic finite automata, again I do write here deterministic finite automata, right? Let us understand what this deterministic finite automata. So I let illustrate with an example to you, with a transition diagram. Explain with a transition diagram. Look at that here. One state, another state, another state. Better let me, I have to count number of states of that. How many states are there here? Q1, Q2, Q3, Q4 and Q5. Let me, these are the two final state of this machine. These are the two final state of the machine, and this is the static state of this machine. So what does it happen here? If you are giving inputs, B goes to the state Q2. If you are giving input A, it goes to the state Q4. If you are giving input here also, it goes to the Q5. Similarly, if you are going to give input B here, it goes to the Q3 state. Okay. So, what is this idea? Idea is that for every state, for each input symbol, there is a transition. So what are the input symbols are here? A and B. For each state, again I repeat, for each state, look at that, for the Q5, the transition for both A and B. For Q5, the transition for both A and B. For the Q1, also there is transition for both A and B. For Q2, both A and B. For Q3. It concludes that definition. What is the definition of this? If you say formal description or description of the DFA, we will give the description of the DFA. Number 1. What we have seen here, description of the DFA. This machine constructed with finite number of states. This is the first point you should remember. There is one initial state, absolutely there is only one initial state in this machine. Number 3, the set of final states. Absolutely, you can see that there are 2 double concentric circles you are finding here. So this point also hold good. For every state of machine, how many states are there? There are 5 states. There is transition for all input alphabets. There is transition for all input alphabet. If you see here, the input alphabet A, B, for all input alphabet there must be transition from every states. So which hold good? You can see for Q1, both A, B, Q2, A, B, Q3, A, B, Q5, A, B, Q4, A, B. This is the condition for the DFA, what we have seen. Next category we will see non-deterministic finite automata. Non-deterministic finite automata. Non-deterministic finite automata. How many are there? There are 2. NFA without epsilon move. Another is that NFA with epsilon move. So try to understand every concept here. Now let us go with NFA, next category. NFA without epsilon move. Let us discuss the formal description or description of this description of NFA. So what is the description of NFA? Without epsilon. Without epsilon. Okay. So let us draw one diagram here. We call it a transition diagram. Let have this move given to you, and let this is the initial state and this is the final state. What I have to do here? I have the transition for both 0 or 1 this side, and let me have only 0 transitions are here. At this point, let me I have both 0 and 1. Here is also 0 and 1. Simple concept. Let me I write here, this is called Q1, this is called Q2, this is called Q3. Try to understand of the NFA without epsilon. You could see that there is no epsilon move here defined. So, what is that idea? If the formal description, or this is called the formal description of this NFA. The finite number, what is that idea? This NFA consists of finite number of states, whom you call finite number of states. That is that the number of states is counted here, which is countable. So absolutely the finite number of states here, capital Q. What are they are called? Q1, Q2, Q3. Point number 2, there is only one initial state. How many initial state? Only one initial state. What is that is called here? Q1. Let's see that there is set of final states. Final states. We denote it is as capital Q. You could have seen that. Sorry, we can denote it as a capital F. Capital F. What is there in the capital F set of final states? Absolutely Q3 goes to here. Yes, we already know that a set can have a single element also. So these final states consist of only one final state. This also hold good with property. Next is that you could have seen that this machine is called NFA. Where you will call this an NFA? If there is any state having more than, try to understand here, more than one transition, for the same input for the same input symbol or input alphabet. Let us take an example here. You can see that if you are at the state Q1, on input 0, it is both going to the state Q1. You can see here it is going to the Q1 as well as Q2. If there is any state having more than one transition for the same input alphabet. So what is the same input alphabet here? This is called 0. For 0, there is transition. There are two transitions. Here is one edge, another edge. It holds good the properties of the NFA without epsilon. Now we will go to the next category, that is called NFA with 3 epsilon more. Okay? Next category is called NFA with epsilon more. What does property hold good here? There may be one move or may have many moves in this definition. Let us go for the formal description. What is that idea? Let us have an example here. We have given language L, which is A comma B whole star. What it is exactly talking about? L is any sequence of A and B including epsilon. Let us we have to design a machine to accept this language. How we will do that? Let us have a common pictures of this. Let us design it. I will tell you the steps also. How we will design, how many minimum number of states required to design, that also we will see here. What I do here, let me, this is my initial state and this is my final state. Give the name of the state Q1, Q2, Q3, Q4. Let us from Q2 to Q3 the transition for both A comma B. You could have write two edges separately or you can write a single edge with level with a two symbol separated with comma. And you write here there is an epsilon move, and there is another epsilon move here, and also there is an epsilon move from here. Look at this picture. I says this is NFA with epsilon move. This is a machine first of all. Which machine is it? Finite state machine. FSM. So NFA with epsilon move, formal description we are going to give you. I have taken this is an idea for you for understanding part of that. Now the formal description of the NFA with epsilon. Now what I have to do that? First point that set up finite states. I hope you people have understand that. That is capital Q. Set up. Next is that initial state. Only one initial state. These also hold good. This property is also hold good. Yes or no? These properties also hold good. Next is that set of final states, that is capital F. Absolutely there is a state in this set of final states. So we can write here set of final states F. You can see this is the property Q1 belongs to capital Q and F is the subset of capital Q. This property is also hold good for all the cases. It is also hold good for the DFA, it is hold good for the NFA without epsilon, it is also hold good for the NFA with epsilon. And the most important point is that there must be an epsilon move. There must be an epsilon move. This is must hold good. There must be epsilon move. And what is that happened that? It is an NFA. It hold good the properties of the NFA. There must be an epsilon move and it must hold good the property, all the properties of NFA. This is the master fact. What we have understand from these three, that these are three different machines we have designed. Give little bit formal definition of all the machine here. Now let us discuss the formal definition. Formal definition of each type or DFA. In some of the books it will be directly, it is finite automata also. What is the final automata? DFA. A DFA is a machine comprised with 5 tuples. What are they are called? 5 tuples. That is, I can write here M within this parenthesis, capital Q, input alphabet, initial state, and what is that? The set of production rules, and it is capital A. If you count 1, 2, 3, 4, 5, hence it is 5 tuple machine. All of you know that the definition of Q, set of finite states and input set of input symbols. We call it as alphabet. And next is that initial state, only one initial state, Q0. Q0 belongs to capital Q. Set of input symbol, finite number of input symbols. That is very important, finite number. Q0 is the initial state, set of production rules, or transition rules, set of production or transition rules. It is very important that how you represent this formula. If you are in a state, you consume an input symbol, you will go to a single state. Go to a single state. That is the most important point of that. And capital F, this is called set of final states. Set of final states. And we can write here F is the subset of capital Q. This is also very important. Now let us talk about the acceptability of the DFA. So whom you call acceptability of the DFA? Let us see here how you define this. I can write here the acceptability. A string X, better to write, we are used to write W here. for every book, almost all the books they do write here. A string W is accepted by the finite state machine DFA, finite state machine DFA, if and only if there is some transitions or set of transitions, there is set of transition that drive the string W after some point to the final state. What is that idea? Q0 is the initial state, and QF is the final state. By some repetition of the steps, you will going to get it here. So this is called the acceptability of the DFA. Can I repeat that? A string W is accepted by the finite state machine DFA if and only if there is some transition rules. That's why I have written here derivation form. Maybe have set of transition rules that drive the input string W from the initial state to the final state. That is called the acceptability of the DFA machine. Next goes to the formal definition of the NFA. As I already discussed you NFA, whether you are talking about NFA with epsilon or without epsilon, simply NFA. So if you see the definition, formal definition, so it is a machine M defined with 5 tuples, right? Input alphabet set. Here is the initial set of transition rules, and set of final states. As usual, the definition for Q, alphabet, initial state, but only difference is that if you are in a state, if you are reading an input symbol, you may goes to more than one state. Sir, why you have written 2 to the power q? Because what is the meaning of that? Move to more than one state. Move to more than one states. That is the concept here of discussion. Because you have q number of states here. Let us take the example here: q0, q1, q2. 3 states, 2 to the power 3. There are 8 number of such possibility. There are such 8 number of such possibility to take the machine from a state to another state. Give the acceptance of this, acceptance of NFA. Whether we are talking about NFA without epsilon or NFA with epsilon, a string W is accepted by NFA, whether it is NFA without epsilon or with epsilon. A string W is accepted by NFA. There is a path. We can also call the completed path. There is a path that read the string and lead to accept state. So let us take an example here. What is this idea? What I am talking about that? Suppose you are in a state like this. I have already told you that let us read 0 or 1. Here let us read 0 or 1. Let me one more move here, 0 or 1. And let me write here it is Q3. This is the final state, 0, 1. This is my initial state. Let me, there is a loop here for, let me, there is a loop here, 0, this is 1. Sir, is it an NFA? Yes sir, it is an NFA. What I have to do here? I look into the acceptance of a string. So, what is the string accepted by this? I can say here, the string is accepted. Look at here that why this topic is called non-deterministic. From this example you will see, let us W equal to, I'll write here 0, 1, 1. Let us take this string. If there is a complete path, we have to find a complete path. Okay? What it does that, if you are in initial state Q0, if you are consume 0, 1, 1, it will, no doubt, it will take you to the final state that is called the Q3 by some repetition steps of that. What I have to do that? Let us see this. How many paths can be created? See the number of paths. And if there is a path that read the string and lead to the accept state, then we say that it is accepted by the NFA, accepted by the machine. What I have to write here? You are in the initial state Q0. Now if I am reading 0, look at the control how it moves. If I am reading 0, it may go to the same Q0 or it may go to the Q1. What we are reading here at this point? We are reading 0. I read this 0. Now let us talk about, we have to go for the 1. From the Q0 you may go to, there is only one path for the 1, you may go to the Q1. From the Q1 you may go to, where you can go here, you may go to the Q1, you may go to the Q2. What you are reading at this point? What you are reading at this point, at this level? 1. You can see this level of this. Here also you are reading Q2. Now, look at that here. Next is that what is happening there? If you are going to give 1, Q1 take you to Q2. Q2. Similarly, Q1, here is also Q1, will take you to the Q2. And from the Q2, you can see that this is called 3. You can go to Q3. There exists a path. What I have read at this point? What I have read here? I have read here 1. So this is a path which is created is a complete path. Is a complete path that lead you from the Q0 to the Q3 final state. So what you have understand from that, you can Q0 to Q1, Q1 to Q2, Q2 to Q3. Why this concept is called non-determinism? If you see the capability of the NFA, the control, look at here, when you are consuming the 0, the control will be at Q0, also will be at Q1. So these concepts lead you to the acceptance of the NFA.